Hello everyone, this is Vikas from the College of SVC Bangalore, Department of Computer Science and Engineering. Today in this session we are going to learn about a brief introduction about Raspberry Pi and its hardware layout, operating systems, and configuration to the program, and about the wireless monitoring temperature system. All about this Raspberry Pi. All this session is under the guidance of Professor Padmavati, Madam, in the Department of Computer Science, presented by Vikasam from SVC Bangalore. Without any delay, let's get into the Raspberry Pi introduction. The Raspberry Pi is a series of credit card-sized single-board computers developed in the United Kingdom by Raspberry Pi Foundation to promote the teaching of basic computer science in schools and developing countries. Several generations of Raspberry Pi have been released. The first generation means the Raspberry Pi 1 Model B was released in February 2012, followed by a simple and inexpensive Model A. In 2014, the foundation released a board with an improved design Raspberry Pi Model B+. Improved A Plus and B Plus models were released and followed by the year later. Raspberry Pi operating systems means Raspberry Pi works under these below operating systems. Various operating systems can be installed on Raspberry Pi through SD cards. Through SD cards, we can install the Raspberry Pi operating systems. Most use a micro SD slots located on the bottom of board. The Raspberry Pi primarily uses Rasp Pi, a Debian-based Linux operating systems. Uh, Operating systems are not based on Linux. Means we can use RISC operating system Pi, FreeBSD, NetBSD, Plan9 from Labs, and Infero. These are the operating systems based on not Linux. We can use the Raspberry Pi on the basis of these operating systems. Various operating systems can be installed on Raspberry Pi through SD cards. Sorry. Operating systems based on Linux based. The XBN, which is used to open source digital media center, OpenSUSE, Raspberry Pi Fedora Remix, Gentoo Linux, Diet Pi, Kali Linux, Arc OS, Nard SDK, Kano OS. These are the operating systems based on the Linux. We can use Raspberry Pi and operate the Raspberry Pi under the basis of these operating systems, which are already based on Linux based. Configuration to the programming Raspberry Pi. Raspberry Pi runs Linux and supports Python out of the box. Hence, for you can run any Python program that can runs on the normal computer. However, it is the general purpose input or output capabilities provided by the GPIO pins on the Raspberry Pi that makes it useful devices for IoT things. Here's a simple program that on the Raspberry Pi based to print a word to print two words hello world. We just use it is also a Python code which is used to print hello world. We use print keyword and two closed braces. We just have to type whatever we want to display in the middle of two double quotations. Monitoring temperature systems. A wireless temperature monitoring systems in IoT, Internet of Things, typically involves sensors that collect temperature data, transmits it wirelessly to a central hub or server, and then processes and analyzes the data for various applications. Here's the basic overview of how such a systems might work. This system might work on the sensor nodes, wireless communications, central hubs, and so on. Let's get into the central nodes. Central nodes are nothing but the devices equipped with temperature sensors such as thermistors or thermocouplers that are placed in the environment to monitor the temperature. These sensors can range from simple low-cost sensors to more sophisticated ones depending on the requirements of the application. Wireless communication. The sensor nodes communicate wirelessly with a central hub or gateway. Common wireless communications protocols used in IoT applications includes Wi-Fi, Bluetooth, Zigbee, LoRa, and cellular 2G, 3G, 4G, 5G networks. These are the wireless communication used for Raspberry Pi wireless monitoring temperature systems. Central hub or gateway. The central this device acts on this device acts as a bridge between the sensors and the Internet things. Temperature from the data sensors nodes and may perform some initial processing and aggregation between the transmitting data to the clouds or local servers. The continuation of the wireless monitoring temperature system, cloud or server. The temperature data collected by a sensor nodes is transmitted to a cloud-based platform or a server for storage, processing, and analysis. For the purpose of server for storage, processing, and analysis. Cloud platforms such as AWS means Amazon Web Services IoT, Azure IoT, or Google Cloud IoT provides various services for managing the IoT data. The data processing and analysis of analysis on Raspberry Pi. Once the temperature data is stored in the cloud or server, it can be processed and analyzed for various purposes such as real-time monitoring, historical trend analysis, predictive maintenance, and anomaly detection. Machine learning algorithms can be applied to the data or extract insights and make predictions. User interface. As we all know that interface is a interface such as web or mobile applications allows user to visualize the temperature data, set thresholds or alarms, and receive notification in the case of abnormal activities, activities under the conditions of temperature. The user interface is nothing but it displays everything of temperature data processing analysis and cloud server which is under the whether it is working or not, or it displays everything of working process which displays the data. That's all about the about the and thank you everyone. This is the end of my slide.